Welcome to the lecture on fossils. I realized after creating the previous lectures on how to establish the relative age of rocks and all those laws that we left out something. Okay, I left out something. You had nothing to do with it. So here's our little talk on fossils. And the reason I forgot it, well, I am a fossil. Here's my latest picture. I think I look pretty good. Dang. Now, this is what people are used to thinking of as fossils. We've got ammonites, or chambered nautilus, as you know them. There are huge ones of these down in the Grand Canyon. When I was doing my master's work down there, ran across some of these polished in the rocks near the oldest part of the canyon, not in the schist, obviously. Here's what people think of, night at the museum. Here's what you find in the stores all over. And here's one of my favorites, the trilobite. A fossil is any remains of past life. Preserved remains, I guess I should say. It's like if you cut your hair off, that doesn't really count. Okay, what do you do if you want to become a fossil? Let's go to here. Well, that's weird. Huh. Oh well. Not too many things are lucky enough to become a fossil. Now, I know that's a little bit weird to say because in order to be a fossil, you have to be dead. And you're not really lucky if you're dead. Although you've been lucky to be alive, so I guess we can't complain. You'll notice the word spelling in here. It's British. But if you are going to become a fossil, here's what has to happen. Typically, you have to have hard body parts, teeth, bones, things like that. You have to get washed out to sea or get buried very quickly. The soft parts are going to rot away, and your skeleton or your teeth are going to be left behind, and they will be preserved only if sediments cover these, and there's enough pressure then to change these sediments into rock. Then this rock surrounds what was your bone. The bone begins to rot away and leave a mold. And then minerals coming through the water take the place of each cell leaving behind from the mold and create a cast. Then this has to get uplifted again, up to the surface, all the overlaying rocks worn away, and then there you are. You probably have a better chance of winning the lottery, to be honest. Now, you have to have bones, teeth, you die. Well, you can get covered up if you're alive. I'll show you some examples of that. And then you have to be in the correct environment. I just told you you had to have hard parts. Not always. Believe it or not, here is a fossil of a jellyfish. Most people wouldn't recognize it, but that really is a jellyfish fossil. Pretty rare. You don't find those a lot. Okay, here's a mold and cast. An organism leaves behind a mold, and then more sediment comes in, fills it in, that becomes the cast. Looks like this is the mold and this is the cast in this case. He had some old clay layer and a new clay layer came on top of it. Hard to tell. These are crinoids. What are they? They're the stems of this thing, which we call the sea lily. These are slightly different versions of the sea lily, but these were around back in Mississippian, Pennsylvanian, and Permian times in the Paleozoic era. We're in the Cenozoic. Before that was the dinosaur era. Dinosaurs like 65 to 265 million years ago. And then before the Mesozoic was the Paleozoic. So these guys are pretty old. You can find these in the North Rim of the Grand Canyon, which is a little bit weird because that means this rock that's now 8,000 feet out of water used to be underwater, and these guys used to be there. This kind of stuff, I can't say it's soft, but it's not hard. It's in between. But because it's on the sea bottom typically, when these things die, they get covered up fairly quickly if there's a lot of sedimentation going on. You can see all kinds of cute little fossils. This is kind of cool. Now this has been done very carefully by an artist. There was an old trilobite. Here is sand. Trilobite died on top of the sand. More stuff came on top. Then digging back down through this, somebody with a grinder ground around everything that wasn't the trilobite. So this is the cast of a trilobite. I don't know if this is a Flexocalamine or a Phacops rana. There are different species of the trilobites, and I don't know them that well. Now, trace fossils. These are, I guess, real fossils. Here's trace fossils. What's a trace fossil? Evidence, but not the real thing. What do we mean by that? Here's an example. Dinosaur comes along and steps in mud. The mud hardens. Sediments come on top of that mud. You then get a rock layer on top of that. And then after a while, you can get the footprint exposed when this stuff is uplifted again, just like we talked about before. Now, what does a four-footed critter look like? Its footprint will look something like this. If you ever see bunnies hopping or dogs walking, you'll see this. People and dinosaurs, some dinosaurs, we tend to look more like this. There are, in the United States and Canada, lots of places where you can find ancient footprint beds, sedimentary rocks where footprints have been left. In California, Washington, all over. Take a look back east. All those sedimentary wiggly rocks that make up the Appalachian mountain ranges over in Texas. And then up here in Arizona at a little place called Moe Nave on the Hopi Reservation, just northwest of Winslow, north of Flagstaff. What can you find there? This. This is sandstone, and in the sandstone is the footprint of I forget the species of dinosaur. You can look it up. Just look up Moe Nave, M-O-E-N-A-V-E, sandstone and fossils. And you can read more about this kind of dinosaur. Now, in Hawaii, here is the Ka'u Desert. And in the Ka'u Desert in 1790, a bunch of people were making their way across the summit of Kilauea, the volcano, trying to get away from Kamehameha. Some people were up there gathering obsidian probably for tools, the women and children, but the men were coming across, and by looking at the footprints and stride size, you can figure out that they were about 1.75 meters, pretty tall. And they got covered up. Can we really call these fossils? No, because they're really soft. They're not really in hard rock. This is just kind of hard ash, which you have to be careful with. You have to walk around this. And just so I can show you what's going on, this is the Ka'u Desert. Okay, let's zoom out so you know where you are. Here's the United States. Here you're sitting in, wave. Oh yeah, I can see you. Okay, let's zoom in. On the big island, Hawaii, the one that's most active. Here is the Kilauea crater. Zoom in a little bit more. Whoa, just lost it. Kilauea crater. My old house used to be right on the edge of this thing over here. And then the Ka'u Desert, oh man, I lost it, is out in this area. And that's where the footprints were. Only 3 people escaped alive from that event. Oh no. There we go. Now, another type of trace fossil, not the real organism, but kind of a hint of the organism. Well, you know what this looks like. But geologists don't call it that. It's called coprolite. And this is the poo of animals. And yes, sometimes because it falls on the ocean bottom or it gets covered up, this gets fossilized. Weird, I know, but coprolite is an area that some scientists study. No kidding. Okay. All around the world, just not in northern Arizona, trees have fallen down and gotten covered. They've got to get covered to be protected from oxygen, rotting, decaying. But if a tree can get covered, and then little by little the wood rots away, and silica-rich water goes through and the silica is left behind, cell by cell that tree can be replaced with quartz. The quartz may be stained with some metals, which is why you get these really cool colors. But you can see bark, sometimes you can see leaves. This is the process of petrification. Here is a rather tan guy hiking out in the beastie badlands of New Mexico, northeastern New Mexico. And here's a piece of petrified wood that looks more like the normal petrified wood, not the really bright stuff like this. And it's so hard it's protecting the clay that's underneath. These are badlands with really soft, erodible clays. Now again, you can find petrified wood all over, not just in Arizona. We just know about ours, and it's famous. Another way to preserve real remains. Southern California. You guys probably don't know this, but it used to be oil fields a long time ago. And with oil fields, you end up with tar. Most of this tar here, probably less than 100,000 years old. Old to you and me, but geologically, not a lot. Here is a picture of the tar in Los Angeles. In fact, let's zoom in on it. These are the tar pits. Oops, there's a little mammoth or mastodon. Let's zoom out. This place really is in the middle of Los Angeles, right near downtown. And it's a really kind of cool place to visit. I think it's downtown. It's all city to me. And we are way over here. So just get in your car after class and go over there and look at the La Brea tar pits, which, by the way, is a slightly weird thing to say. La Brea tar pits, some of you know, means tar pits, tar pits. What's in the tar pits? Well, here, the saber-toothed tiger. About a foot shorter than the common tiger, but it's about twice as heavy. These guys were massive. This is what the tar looks like. They have found lots of these guys down in here, and there is an artist's conception that they've stuck back in there. They are still digging. Again, most of the stuff, usually around 50,000 years old, some up to 100,000 years old. Gotta hurry. Frozen remains. Every once in a while you find stuff in the last 50,000 years typically that's been frozen up in the permafrost. Now these guys are becoming unfrozen as we warm up the planet. Here's one called Dima. Let's see, 40,000 years old. Something kind of interesting. The ears are really small, but when you think that this lived in the really cold areas of the steppes, it makes sense to have smaller ears so you wouldn't lose so much heat. Some of you know about this. If you saw the movie Jurassic Park, you know about this. Getting dinosaur DNA from a mosquito trapped in amber. Amber is the sap from trees. Baseball players know it as rosin because you grind it up and use it in your hands to get a better grip on the bat. But sometimes you find organisms caught in the amber. One more thing. Sometimes leaves get caught in shale, clay, and they rot. But all that is left behind after a long period of time is the carbon. So can we call this a real original remain? Kinda. It left an imprint, so it's kind of like a trace fossil or an imprint. But the leaf isn't really there, it's just the carbon from it. Now, a lot of times people get this confused with this. This looks like leaves, but it isn't. These are little crystals of manganese, or magnesium, can't remember which one. A metal. And when it gets in between layers of sand or silt, it can leave these little crystal patterns that look for all the world like ferns. Not. And one last thing, your book doesn't talk about this, microfossils. These are very handy for paleontologists looking for the right age of rock in which to drill for oil or petroleum. That's it. Thanks for watching.